All right, so let's take a look at how we would actually make a confidence interval. All right, so we survey 100 adults and we ask who was the greatest president. Okay, of those 100 people you survey, 19 of them tell you it was Abraham Lincoln. Okay, he was the greatest president. So, first thing, what is the point estimate for the proportion of adults who think Lincoln was the greatest president? So, point estimate is a new term we got just in the last section, but just as a reminder, that's like the results of your survey. Okay, so what did your survey tell you? Well, our survey told us 19 out of 100 people thought Lincoln was the greatest, and the symbol for that we're going to use is p hat. Okay, so an estimate for the population proportion. So 19 out of 100 people, or 0.19. Okay, again, pretty simple enough. So just keep thinking to yourself, the point estimate is like the results of my survey. Okay, it is based on your sample, either p hat or, in the event of a mean, x bar. All right, given a level of confidence of 95%, construct a confidence interval for the population proportion of U.S. adults that think Lincoln was the greatest president. Okay, so remember, our 19%, okay, our 0.19 lies right here. This is what we got, and we know that we have this error, right? We want to go out so far, and the question is, how far do we go above and below 19% to say that that's our target? Okay, how far above and below do we go to say this is the target? We're 95% confident. Okay, there's a 95% chance that the real percentage of all U.S. adults that think Lincoln was the greatest is between here and here. Okay, got to give ourselves that range. So the way we're going to do that is using your calculator. And we are going to do what is called a 1 proportion Z interval test. Okay, so to do that, what you need to do is press your stat button. Okay, then you're going to arrow over to tests. And then you're going to go down. Now be careful, there's a 1 proportion Z test. That is not what you want, okay? You want 1 proportion Z interval. And for me, it's item A. Okay, now for you, again, it's usually close by to A, but for sometimes when it's my A, it's your B or vice versa, okay? So make sure you're finding 1 proportion Z interval, not test. Okay, then go ahead and hit enter, and you should see the following things come up on your screen. You should see X, you should see N, then you'll see a C level, and then you'll see calculate. Okay, so for the X is how many people of those surveyed responded, in this case, that they thought Lincoln was the greatest. So your X is your 19, okay? N is your sample size, and your confidence level is the 95%, and put that in as a decimal, so 0.95. Let's go ahead and get that typed in, and then go ahead and hit calculate, and it should return some values to you. There'll be 3 things. The first thing you should see is the interval itself, okay? It says round to 3 decimal places, so I'm getting 0.11311 actually, if you want to do the full, and then on the upper 0.26689 or 267. Okay, there is my confidence interval. Notice it also gives you p hat is 0.19, okay, which we already knew. We found that back in part A, and then it tells you what your sample size is again, all right, even though you just typed that in. So what is the margin of error? So remember, this 0.19 is right here smack dab in the middle. Now in this case, you've got 2 ways to do the margin of error. You can do what we did in the last video, take your upper boundary minus your lower boundary and divide by 2. That certainly works. But since we know 0.19 is in the middle, we also have the option just to figure out how far 0.19 is from either the upper or the lower boundary, because we already know the middle value. On the previous examples, we didn't know what that middle value was. So I'm going to give you 2 ways to do this. You can either do the 0.267 minus 0.113 divided by 2, and that'll work. Or you can take that Again, either 0.267 minus 0.19, or you can do 0.19 minus 0.113. Either one, it really, any of those three actually, it makes no difference to me. Regardless, you will find out that your margin of error is 0.077 or 7.7%. Okay, and again, I'm not trying to confuse you, but when you know what p hat is and you know p hat is in the middle, it might be easier to do one subtraction than to subtract and divide by 2. All right. So then the last thing, interpret the statistical meaning. Okay, so the statistical meaning, we're going to get, the little fancy version here. So we did a 95% confidence interval. So there is a 95% chance the true proportion of U.S. adults who think Lincoln is the greatest president is between 0.113 and 0.267. Okay. If you don't want to use proportion, you could say there is a 95% chance the true percentage of U.S. adults who think Lincoln is the greatest president is between 11.3% and 26.7%. Okay, what you would need to do is just change your proportions to percentage forms, including the word proportion. Okay, so again, we took an estimate. We know our estimate isn't perfect. Okay, we sampled 100 people, not all of the hundreds of millions of adults in this country. We got 0.19. We know there's some error. Okay, in fact, we figured out there was 7.7% error, 0.077 for our margin of error. So we're 95% confident that the true proportion of Americans who think Lincoln was the greatest is somewhere between 0.113, 11.3%, and 26.7%. There is a chance we missed the mark, okay? There's a chance that we threw the dart and we are not within, like, the actual value, we were outside of the target, okay? That's possible. We might have thrown it at the dartboard and we might have hit the wall and our dart might have bounced, and that's okay. We don't know for sure, but we're 95% confident that we captured that value somewhere in that interval.